we have a circle. And this is a center. I use this different color. And this is AB. And the center angle, X, equals to AB. Center angle equals to the central angle to intercepted arc. You can't make mistake because it's so easy. The vertex belongs to the center. Next case, B. You have a beta circle. We have a beta circle, again, summarization. And we have angle, which is inscribed. In this case, and let's say this is arc AB as well, for this case. And this angle X is inscribed angle. Why it's inscribed? Inscribed angle vertex of this belong to circumference. And this angle X equal half of intercepted arc. Any questions? Somebody wrote notes. Do you have any questions? No questions. Now, case C. I have a circle. Again, not the best circle, but imagine that this is a circle. And you have two chords. And this angle between two chords, the chords, this angle X. And there are arcs AB and CD. Angle between two chords equals angle X equals 1/2 AB plus CD. The same, half of the sum. Any questions so far? No questions? Okay. Case D. We have a circle. We have point outside the circle and we make tangent. This line is touching this at one point. Okay. And second line is secant. This is tangent. Tangent has common point with circle, one common point is touching this. And secant just cutting this. This is secant. And let's say this is circle, center. And we have H, B, point of tangency, and C. So this angle X angle X equals half of different intercepted arc. This arc AB, whatever number you have, minus arc BC. We have few cases. Is D1, D2. In D2, we have a circle, and we have two secants. This is secant, as well as this one. And we have this angle X. And we have the same situation, AAB and CD. Okay. Well, in this case, this was common point. Now there's different points. The same formula. This angle X between two secants equal half of difference in intercepted arc is BA minus CD. The next case, D3. Okay. I put one tangent. Let me use a ruler. This is one tangent. And this is another tangent. You see it touching this circle in one point. Two tangents. This is center. This point A, this is point B. And this is, I take red color as usual. And this is point X. Angle X. So angle X is exactly the same. Half of difference of intercepted arcs, AB. This arc. Minus arc, AB large, minus AB small, let me put this way. From this, we name it major and minor. And finally, the last situation, E. If we have a circle, and we have point outside the circle, very important theorem. And I make two tangents. And this is point of tangency. Points of tangency. And this point outside the circle. Distance AC equals to BC. Distance from point outside of circle to point of tangency is the same. For this AC, they congruent. Segment AC, not arc, AC equals to BC. And one thing you have to know, if you connect any point, if you connect the center with point of tangency, this angle always would be 90 degrees. Always. So tangent is perpendicular to radius and point of tangency. Just these few facts you're supposed to know. If you know this fact, you solve any problem related to circle from this handout or from different tests. Just these cases. I spent a few minutes to remind you because based on your question, I see you have difficulties. Who has question about this?
Dr. Faber?
Yes.
Can I go over again from the situation D3?
Which one, D3?
Mm-hmm. Yes.
This one. Look at this. Let me take this again. In D3, this is for if this point C outside of circle, I make two tangents to point of tangency. And we have two arc, this arc, major arc, AB. I can say AB minus AB is 0, but they is not the same. Let me distort it. Let me make this situation. Okay, look at this. This is C, this is A, this is B. Can you see, Alexander, that this AB is big one, and this we name it major AB. And this also has name AB, but this is small one, minor. This angle X, could this look like almost a me in the middle? I distorted deliberately. And this angle X is half of this big arc minus this small. For instance, if this arc, let's say, is 240 degrees, this large arc, and this respectively must be 120. Why 120? Because overall they're supposed to give 360. So based on this formula, angle X, I plug into this formula, equals 1/2 of 240 minus 120, which is 120 divided by 2 is 60 degrees. And you, in one shot, you found this angle. Alexander, how better?
Yeah, I think, wait, and the AB smaller arc, it's equal to 120 degrees, right?
120.
Okay, thank you.
Why? You can check, because arc is, if you add all this both arc together, you're supposed to get circumference, right? The circle is 360 degrees. So if one is 120, second must be what? 240. Good. Any more questions, students? Good. Review this. This is your tools. Because all questions very easy, but you know all of this, the theorems. Well, few more questions related to your let me see, for diagnostic, right? Diagnostic. Let me see what you have diagnostic very fast.